Hey everybody, the focus of today's video notes is on a concept of solutions called the concentration. You probably understand the concept of concentration based on how strong a drink tastes. For example, if you have really strong coffee, it's got a very bitter taste to it and the color is very dark. That is what we call a highly concentrated cup of coffee. But in chemistry terms, the idea of concentration is how much solute is dissolved in a particular amount of solvent. The more you dissolve into the solvent, the more concentrated a solution becomes. The opposite of concentrated is a word called dilute. Here's an example of two different pictures showing one that's concentrated and one that's dilute. The picture on the left represents a beaker filled with 200 milliliters of water. So that's what this level of liquid inside this beaker represents. And we have 7 molecules of solute in 200 milliliters of water. We'll call this the concentrated solution. But to be concentrated, you have to compare it to something that is less concentrated or dilute. So if you look over here on the right, you'll see a picture of a beaker with twice as much water in it. Now we have 400 milliliters of the water, but we have the same 7 molecules in a larger amount. So that the particles can spread out more because there's more water inside the solution means it's less concentrated. As scientists, we like to think of concentration as a ratio or a fraction. The beaker on the left has 7 particles out of 200 total, and the beaker on the right has 7 particles out of 400. Now, we can see that the one on the left is more concentrated because there's less room for these particles to move around in, so they're more tightly packed. Another word for concentration is tight, packed, or dense. Usually when you see things that are concentrated, if they have a color, the color is deeper and more vibrant. And the example I used before was the coffee. A concentrated cup of coffee is dark, black or dark brown, but a dilute cup of coffee has a see-through or a light brown appearance to it. Now, if you think about it in terms of a mathematical relationship in the form of a fraction, both of these have the same number of particles in the top of the fraction, but the number on the bottom is different. I like to think of these particles as little sheep, and they have the ability to roam around in this size enclosure. But if you double the size of the enclosure, they have the same number of sheep in a larger enclosure. So they are less concentrated. If you put the same 7 sheep in a small space, they are highly concentrated. And if they're the same 7 sheep in a wider open space, then they are less concentrated. Now, we talked about it a little bit on the last slide, but in this particular slide, we're going to talk about the quantitative concentration. We're not going to talk about it just as like a picture and as vibrant colors or dull colors, but we're going to talk about actual numbers. Now, there are many different ways to express the concentration of a solute dissolved in a solvent. But to keep things simple in our class, I'm only going to use this expression of concentration. And we're going to be talking about dissolving grams of a solute or a mass of solute in a specific amount of milliliters of water. So here's the example that I'm going to start out with. I'm going to take 10 grams of salt in the form of salt crystals, and I'm going to put it into the water and stir it up until it all dissolves. Now my concentration is 10 grams over 100 milliliters. Usually though, we express this in a number that's as small as possible. So I literally take these two numbers and I divide them. And when I take 10 grams divided by 100 milliliters, the number I get is 0.1, and that's the concentration of this salt solution, where I took 10 grams and divided it into 100 milliliters of water. 10 divided by 100 is 0.1. Now I'm going to take the same 10 grams of salt, and instead of dissolving it into 100 milliliters of water, I'm going to dissolve it into 50 milliliters of water, and I'm going to see what happens to my concentration. So my volume went down. Now if I take 10 grams and divide it by 50 milliliters, I do 10 divided by 50, my answer is 0.5. So what that means is that my concentration increased when the amount of liquid that I used decreased. And I wrote that down here on the bottom because that's a really big deal, and that's definitely going to be a quiz and test question coming up. If I want to make the concentration go up, I can take the same amount of salt and put it in less water, and the concentration will go up when you have less water. Now I'm going to do a third situation, and I'm going to go back to my original 100 milliliters of water. As you can see, the line of the water is about the same as the one over here. And originally I had 10 grams into 100 milliliters, which means my concentration was 0.1. But now I'm going to do 25 grams into 100 milliliters. So I'm going to increase the amount of salt that I put in, but keep the amount of water the same. So now my math is 25 divided by 100, and my answer is going to be 0.25. So again, my concentration went up. If I compare the concentration here of 0.1, 0.25 is larger than 0.1. So another way to get my concentration to go up is to add more salt. And that's another very important observation to make, and one that I'm going to talk about again by writing it down here on the bottom next to my other one. The other way to make concentration go up is to add more salt to the same amount of water. So in other words, there's two ways to increase the concentration of a solution. Either decrease the water to make the concentration go up, or increase the salt to make the concentration go up. Now, of course, the opposite of these statements are true. If I want to make the concentration go down, if I want to make a more dilute solution, then concentration down means water goes up. Just change the direction of the arrows. Or if I want the concentration to go down, I want to add less salt rather than adding more. I'm going to finish today's conversation with one more example, but instead of this time calculating the concentration, if I give you the amount of salt, I'm going to give you the concentration. I'm going to ask you, how much salt do I need to go into 500 milliliters of water in order to get the concentration to equal 0.75? So let's set up a formula that you can use time and time again where you can plug in the numbers and just solve. Here's the formula. Concentration is equal to the grams divided by the milliliters. And I will always give you two of these three things and ask you to solve for the missing one. Now on the last slide, I gave you grams and milliliters and I said just divide them to solve for concentration. Now I'm going to give you the concentration and I'm going to give you the milliliters, and I'm going to ask you to solve for X number of grams, or we'll just call it G for grams on top. So 500 on the bottom, 75 or 0.75 on the left. Now I need to solve for grams. In order to do this, I'm going to go back to my old trusty cross multiply. Now, in the previous times we cross multiply, we always have one thing over another. And in concentration's case, I don't have a number on the bottom, but I can just put it over 1 and now I have a bottom. So now I have a top and a bottom on each side of the equal sign. Now all I need to do is cross multiply. And if I take 0.75 and times 500, I set that equal to 1 times G, or grams. Well, 1 times grams is grams. So in other words, all I need to do is take 0.75, the concentration, and multiply it by the volume, and I should get the number of grams. And the answer is 375. In other words, I calculated that I need to put 375 grams of salt into this 500 milliliter beaker of water in order to get the concentration to be 0.75. Let's do one more example. This time I'm going to say the concentration is going to be 3.0. How much salt do I need to put into this beaker of water if I want the concentration to be 3.0? Now, I need to specify how much salt I need. So 300 milliliters seems like a nice even number. And the concentration needs to be 3.0. Now, I set up my numbers. 3.0 is equal to X number of grams, or just grams, over 300. And now I need to solve for the grams. So I put 300 on the bottom, grams on top. I put 3 on the top and 1 on the bottom, and I do cross multiply. But 1 times grams is just grams, and then 3 times 300 is 900. So in other words, if I want to calculate how many grams it takes to get a concentration of 3, I just take 3 times 300, or 900 is the final answer. So I need to put 900 grams of salt into this beaker of water in order to get the concentration to equal 3.0. Well, that takes care of this video lesson. I hope you enjoyed it. I hoped you learned something about concentration. Thanks for watching.